Sample problem 18.2 begins some of our quantitative aspects of acid-base chemistry. And so if we look at our second skill here and look at acid-base parameters, we can see that there's a whole host of equations that are going to allow us to think about many useful quantitative aspects of acid-base chemistry. And so this problem tells us that we have a research chemist adding a measured amount of HCl gas to pure water at 25 degrees C, obtaining a solution where the H3O plus concentration is 3 times 10 to the minus 4th molar. We want to calculate the hydroxide concentration, and then answer the question, is the solution neutral, acidic, or basic? Well, just to kind of highlight and have people understand, when we have HCl gas that we're bubbling into water, what that means is that we're going to have an HCl aqueous solution, which really, because we have a strong acid, dissociates into H plus and Cl minus ions. And we've already talked about the fact that H plus really doesn't exist. When you have HCl in water, that means that this strong acid is going to give up its proton to water and make H3O plus. So I'm okay if you write H plus Cl minus. It's just kind of a simpler way rather than always having to write out H3O plus. But understand that H plus doesn't really exist in solution. So that's kind of the qualitative aspects of this problem. This problem is asking us to calculate OH minus concentration when we're given H3O plus. And that requires us to think about this equation, that Kw is a special number, 1 times 10 to the minus 14th, and that's equal to the hydroxide concentration times the H3O plus concentration. And this is important because it tells us that these two parameters are inversely related. So if we increase the H3O plus concentration, that must mean that the OH minus concentration must decrease, such that their product is always equal to 10 to the minus 14th. Again, if we have these two species being equal, we have a neutral solution and their concentration will be 10 to the minus 7th. So we'll get to some of those aspects later. But this problem basically tells us that we're given H3O plus concentration and we want to find OH minus. So to solve for OH minus concentration, we're basically just going to have our H3O plus concentration and we're going to divide by 1 times 10 to the minus 14th. So rearranging this equation. So putting in our parameters here. So again, oh, and I got this wrong. Sorry about that. If we're solving for OH, we're going to have 1 times 10 to the minus 14th over our H3O plus concentration. Apologies for that. So now when we put in our H3O plus concentration, we have 3 times 10 to the minus 4th, so that's the value that's given to us. And we can see that the OH concentration is going to be equal to 3.3 times 10 to the minus 11th molar. And so to ask the question, is the solution neutral, acidic, or basic, we have to compare the OH minus concentration to the H plus or H3O plus concentration. So H3O plus concentration, again, is 3 times 10 to the minus 4th. OH minus concentration is 3.3 times 10 to the minus 11th. And so when we have this situation here, we can see this is going to be present in greater amounts, which means we have an acidic solution. So kind of a classic, not trick question, but making sure that you understand things questions, is I will give a problem and I'll say, is the solution acidic, basic, or neutral? And I'll tell you that the OH concentration is this number. Well, just because you have OH does not mean that your solution is basic. And people just see, oh, I've got hydroxide. They don't even look at the value of the concentration and they say that the solution's basic. But remember, if you have an OH minus concentration, a hydroxide concentration that's this small, your H3O plus concentration is significantly greater. When H3O plus is greater than OH minus, you have an acidic solution.